So this is an AP class. Doing this, just being in this class, you guys are getting a bump in your GPA, that, and the most of you are going to get college credit for this. My passing rate is 74%. So the work we have to do in between, we have to do, okay? I work my tail off to make sure I fit everything within a class period. I go through the notes painstakingly. I choose the homework problems, annoyingly so, right? Skip this one, do the odds of this one, because my goal is always for you to get work done in class. That's always what I want. I want that. I don't want you guys to have homework. I really don't. But sometimes you're going to have homework, and maybe this is one of your homeworks, is to start practicing this. I went ahead and put this on Canvas. I have a program that just can regenerate as many problems as these as I want. I put a whole blank one of these with 36 of the problems, and if you keep scrolling, the key. So if you are serious about learning this, with which all of you need to be, take some time. In other classes, you're done with something. You have some extra time at night. Practice these. Once you get it, it's there. You never have to worry about it again, and the stress is gone anytime we have a trig question, okay? If you don't learn this, you're going to be stressed. You're not going to do as well on tests and quizzes because you have to know it, okay? Sorry, I had to lecture you. The biggest thing I have learned today, and maybe you guys, this class that I always brag about and compliment, maybe this class can help me understand, and I've asked every period this, and no one has an answer. I'm having the hardest time understanding what I'm doing wrong, I take it, that people don't understand this, okay? So I am going to take a second and really explain this. So, first of all, these are, all students take calculus, those letters, quadrant 1, 2, 3, 4, right? All students take calculus. These letters represent who is positive in each quadrant. And these letters stand for, there's 3 letters, that's it, right? Sine, cosine, tangent. Sine, cosine, and tangent is represented in every one of these quadrants by one letter telling you everything, okay? So sine, S is for sine, T is for tangent, C is for cosine, okay? A is for, Nathan, what's A mean? Oh. And if this represents who is positive, sine is positive, cosine is positive, tangent is positive, okay? Quadrant 1, everyone gets by, all right? Now let's go to quadrant 2. I see an S there. S is who is positive. Sine is positive. What are cosine and tan? Yeah, guys, you can only be positive or negative. There's no other options. It's a 50-50. And so if you see the letter there, it's positive. If we're talking about quadrant 2 and the letter isn't there that we're talking about, like T or C, that means they're negative, okay? And the whole purpose of this is I can, at a quick glance as I go through my quiz, just glance over there. I can tell exactly who's positive, who's negative with a quick glance, or in my head if you don't want to write it. So who is positive in quadrant 3? No. Tan is positive. Okay. Yeah, all right. Tan is positive. So the only other option for the other 2 is negative. Okay. Yes. Cosine is positive, sine and tan are negative. Is there anybody brave enough to tell me that they struggle with this? Anybody? Peter. Okay. Thank you. Who else is that raising a fish? Okay. All right. There's a reason for this. I need to reach you guys. I need to. And I will do a backflip if it's possible to make you understand it, okay? No, I can't really. I said if possible. No, I said if possible. So just looking at this, because you're not going to write all that. So, Peter, I'm in quadrant 3. Do you know the quadrants, 1, 2, 3, 4? Yeah. Okay, I'm in quadrant 3 and I'm talking about cosine. Is it positive or negative? No! I'm not yelling at you. Quadrant 1, 2, 3, 4, right? Yeah. Yes. That's right. Christian, quadrant 4, what is sine? No. Look here. Let him answer it, guys. Quadrant 4, sine is positive or negative? Do a backflip. Who's that? It's like, okay, remember, the letter you see is positive. Anything else, so a letter that you don't see, and it's only 3 letters, right? Sine, cosine, and tangent. If you don't see that letter, it is what? Negative. Okay? Peter, quadrant 2, tan. Yeah. Is that a guess or do you know it? You? Yes? Christian, quadrant 3, tan. T. T is for tan. Right? If you see the letter, it's positive. Somebody that used to be confused about it that gets it now, can you put it in other words for me to help? Because I am getting this in every single class. I'm having this little this little hissy fit I'm having because I can't figure out what I'm not explaining well. And it's got to be me. It's got to be me.
I don't know. I didn't
Your tutor's not better than me.
I didn't understand that. I didn't understand that there's something that I know. It's a pattern. If it has the letter, it's positive.
That's it. If you see the letter, that letter, which represents the word, is positive. If the letter isn't in that quadrant, it is negative. That's it. Peter, am I getting through?
Yeah, that's
Okay, that's good. Thank you. Go ahead.
Yeah, that's what I'm doing.
Okay, okay. Love it. Take it. Internalize it. Now I'll explain it. Again, the unit circle, guys, is, I know you guys think of these as ordered pairs. The unit circle is cosine sine, cosine sine, cosine sine, quadrant 1, cosine sine, cosine sine, cosine sine in quadrant 2, and so on. Remember, all of your x values are your cosines and your y values are sines. Where the heck did tan come from? It came from doing y over x. So you make a fraction out of those two numbers. A positive divided by a positive is positive, and a negative divided by a negative is positive. So that's why tan is positive in those quadrants. Does that help anybody? I mean, okay, listen, you don't have to use this for this, okay? It works for me. It's clearly not working for everybody, okay? So if I'm asking you for cosine of 7 pi over 6, let's just talk about what quadrant that's in. That would be quadrant 3, right? So when I'm trying to figure out if this is positive or negative, it's one or the other, my answer. By the way, it's square root of 3 over 2. But is that positive or negative? If you don't like my all students take calculus trick, fine. Cosine is the x value, right? So if I go, like maybe I do this in the air, it's another way of doing it. If I go to quadrant 3, I'm going to the which direction first? Left. Is that positive or negative? Negative. So that tells me this is negative. Or you can say the letter C is not in quadrant 3, so that means it's negative. Okay? Figure out what works for you. I can only just keep throwing all the different things at you, but we've got to get it somehow. And if somebody else comes up with something else that they think of or that might help your fellow classmates, I'm all ears. I'm going to keep working with those of you that are really struggling with these things. But let's see if we're going to do 10 of these a day. And everyone's going to get a 30, yeah, it's going to take us 5 minutes. You're going to get 30 out of 30, everybody, okay? We're going to do 10 today, we're going to do 10 tomorrow, we're going to do 10 on Monday, and at the end of class on Monday, we'll do our first of however many we need forgiveness retakes, okay? So we have until Monday, and we can raise this grade. So let me model for you again. I'm throwing at you everything I can think of. You decide what works for you. Anything, if you don't need this, don't write it. If it's in your head, you don't want to waste the time, fine, okay? You don't have to write that. If you don't, I'm going to basically show you the maximum amount of work that I would show or do or think about for each of these. You can scale it back at whatever level you need, at whatever point you need. I'm not checking your work, okay? So here is the process. If I see it, I always start with the denominator of 4, and I grab my ordered pair. All of my denominators of 4 are square root of 2 over 2, square root of 2 over 2. My numerator tells me it is quadrant 1. Everybody be positive in quadrant 1. Sine is your y value. There is my answer. Right? Stop me at any point if you don't understand something I say or do. Please, please, please. This is your time. This is for you. You're still going to get your homework done, okay? Denominator of 6. Square root of 3 over 2, 1/2. I mean, we got to know that, and I think we know that, right? Denominators of 6 always start like that. Numerator tells me I'm in quadrant 1, right? Pi. Everybody's positive in quadrant 1. Sine is the y value. Answer is 1/2. Okay? Let's keep going. Denominator of 4. All of my denominators of 4 are this ordered pair. Numerator. What quadrant is this? This one. Yep. This is quadrant 4. Remember, top is bigger than the bottom by more than 1. Right? And in quadrant 4, oh, sorry, this, look, cosine is positive in quadrant 4. Because there's a C there. C means we're positive in that quadrant. Okay? Pi, that's a quadrantal. If I were taking this quiz, I would write this. I need to see the quadrantals. It just helps me. It's easier than finding the ones and the zeros and the negative. It's just faster for me to write it one time and then just look at it. Sine of pi, here's pi, right? Sine is the y value, 0. Right? Denominator of 6, square root of 3 over 2, 1/2. Numerator tells me I'm in quadrant 3. Difference of 1. Guys, remember, these are pi. These are 1 less than the denominator. All of these are proper fraction. Numerator is less than the denominator. Numerator in all of these is 1, and then these are all just subtract 1. All of these are improper fractions, right? Because we're more than 1. So the numerator is going to be bigger than the denominator, all down here. Improper fraction, it's 3 or 4. How do you tell the difference? Add 1 to your denominator, and then these are just, okay, we would add 2, so it's just some other number, okay? Subtract 1, add 1, lots more than 1, okay? So this is it's an improper fraction. Difference of 1 puts me in quadrant 3. Cosine is the x value. Cosine is what in quadrant 3? Negative. Michelle, why? How did you know that so fast? You said it so fast. Because T is positive. T is positive. This is not T. This is C. C is negative. Okay? Denominator of 6. Ooh, I wonder what that ordered pair is. How many times are we going to write that? So decide if you need to write it. Maybe you don't. Okay? Denominator of 6. There's my ordered pair. Numerator tells me I'm in quadrant 2. Sine is the y value. What is the sign of sine in quadrant 2? Positive, because there's an S there. S is positive. Sine starts with S. 1/2 is positive. Okay? Denominator of 6. What's the ordered pair? Oh yeah, square root of 3 over 2, 1/2. I mean, right? Cosine is this one. We are in quadrant what? 4. Right? Difference is much more than 1. In quadrant 4, cosine is positive because it's a C. This is a C. That's a C. This is who's positive. So square root of 3 over 2. Okay? Denominator of 4. Square root of 2 over 2. Square root of 2 over 2. Numerator tells me I'm in quadrant what? 2. It's 1 less than the denominator. It's a proper fraction, so it's got to be in the top half, and it's not pi. That leaves us with quadrant 2. Cosine is this number. In quadrant 2, cosine is negative. Denominator of 4, square root of 2 over 2, square root of 2 over 2. Numerator tells me I'm in 3, because it's 1 more. And it's cosine is the x, right? Cosine, sine. And cosine is not tan, so this is negative. And here's our one and only tan today. Remember the tan tricks. I don't bother with an ordered pair with the tans. I just remember, oh yeah, she taught me that trick. Denominator of 6 is square root of 3 over 3. It adds up to 6. Remember that little trick I taught you? And we are in quadrant what? 3. Tangent is what in quadrant 3? Positive. Okay? Does anybody feel any better today? Even if you're not 100%, does anybody feel better? Better? We're getting Tathan good. Okay. He said he was feeling better, so you know. So listen. If you are struggling or not getting 100% every time, you have to put time into this. It's not pi, it's square root of 3. Because it's tan. Remember our tan tricks? Subtract. Okay. So guys, again, that paper and the key, that paper that we just were working on and the key are on Canvas for your practice, pleasure, yes. It is not an assignment. I'm not checking to see if you did it. This is where you guys have to take ownership of what you know and what you don't know. I mean, I have 140 of you have got to get this into your brain. You guys got to do a little bit of work on your own for this, okay? But I'll do anything I can try to help you guys. I just, it's like my biggest goal in life is for all of you to be like, this is so easy, it's annoying. I want you to be annoyed with me. That's what I want. I want you to be annoyed with how you do it. Okay, we're not there yet, most of us. All right, let's get started. Nice and easy, super easy review of sine and cosine. Just putting everything we've learned on one assignment. Let's remember sine has really the only difference between these two is the pattern. In sine, it's middle up, middle down, middle, middle up, middle down, middle, and cosine starts up, up, middle, down, middle, up. And remember, our ups are our maxes and our downs are our mins, and the m's are the middle, usually 0, but if there's a midline that affects it, we'll see all that again. The domain of both of these is all real numbers. It keeps going and going in both directions, so don't get hung up on the fact that a lot of times we just graph like 5 points, which is one cycle. It does keep going in both directions. Range is, in the parent function at least, from -1 to 1, but that changes, right? Sometimes by what? What will change the range of one of these graphs? The what? Not the flip, because the A is coming up. Amplitude, right? That's how high or low, above and below the midline we go. So if your amplitude is 3, you go up to 3, down to 3, right? And don't forget, it's always positive. Period. Luckily, the period is the same. The formula is the same for both of these guys. And remember, the period is how much of the x-axis we use to make our 5 points. It's a length. It's a length. And that's 2 pi in the parent function, and if there's a b value, we just have to change that period. And remember, b is the number that's in the parentheses hanging out with x. We'll see all that again. It's the same formula for both of these. And we haven't talked about symmetry, and I'm not going to go too deep into it, but symmetry is either odd or even. Let me go over those real quick. Sine has odd, also known as origin symmetry, and that just means that opposite or diagonal quadrants are the same. How we go middle, up, middle, down, middle. This would keep going, whatever, in that direction. These quadrants are the same. These quadrants are the same. And even symmetry, also known as y-axis symmetry, means that if I could fold my graph along the y-axis and fold it, all of those points would match up. Okay? We've seen it before. I don't even think we need to make a big deal out of that. We don't really talk about it a whole lot. There is a new letter that we'll start working with, I think Monday. But I'm just going to introduce you to her real quick. She's C, right? We know A, we know B, and we know D. Amplitude, B affects the period, D is your midline. Remember how high or low? C, you're going to start seeing her creep into some of your problems. Not really going to change anything we're doing today or tomorrow, but you might see it there. And I just want to give you a heads up. That's like your H and your K. That's your left or right movement. That's your up or down. Not really a vertex here, but yes, it is vertexing some graphs. And notice the C value is in the parentheses, so it's opposite. Just like all H's are, if you go to the right, it'll be a negative, left is positive. We'll talk more about that another day. I just wanted you to know, you might see it now. This word sinusoid or sinusoidal graphs are sine and cosine graphs. What this means is this. Let me show you with this next graph. What we're going to do in example 1 and 2 is find the period from the graph or the equation. Stuff you already know how to do. We'll review it real quick. You got this. But notice there's no equation that matches this. Some of you might look at this and think it's a sine graph, but you could also think of it as a cosine graph. Same with this one. Like, we always start graphing at 0, 0. So if I start at 0, 0 and I go middle, up, middle, down, middle, first of all, what's the period? Pi. Remember, 5 points. Middle, up, middle, down, middle. That gives me my 5 points. That would be a sine graph. But when I introduce a phase shift to you, that will take all those points and move them either right or left. So that could make this be your first point or this be your first point. So depending on where you start, so let me say this a little differently. We always start graphing from 0, 0 with our pattern of middle, up, middle, down, or up, whatever the pattern is, unless there's a phase shift, which we haven't had yet. But just understand that eventually I'm going to be giving you where this isn't the first point, this is the first point. So that's up, middle, down, middle, up. That's actually a cosine graph that's been shifted to the right, however much. Okay? Don't overthink it yet. For right now, and whether there's a phase shift or not, all you need is 5 points to count your period. And it's easiest to start at 0. So this would be up, middle, down, middle, up. 1, 2, 3, 4, 5 points from 0 to pi over 2. My period would be pi over 2. So you could start anywhere and go out 5 points, but just understand it's easiest to start at 0 and go out. And then your answer is just wherever you land, right? All right. Period in an equation, remember, you can grab a period off of a graph just by counting your points, but you can't just grab the period out of the equation. It's hidden within the b. Remember, b affects the period. We have to do 2 pi divided by our b value. Simplified, that's done. There's my period, right? 2 pi divided by b. That's the period of that one. How about this one? Now listen, guys, x over 3, that's the same as 1/3 x. Okay, those mean the same thing. Just like this problem right here could be 1/2 pi. It's pi over 2, half of pi. You could write it either way, okay? So the b value here is 1/3, is the point I'm trying to make. It's 1/3. So to find my period, that's 2 pi always on top, divided by b. And you have to know how to do this without a calculator. Anytime, and I've done this before, I'm just reviewing, whenever we divide by a fraction, we use that keep, change, flip method. You keep the numerator exactly as it is, change divisions to times, and flip the denominator. When I flip 1/3, I get 3 over 1, 6, 5. Okay? Keep, change, flip. Anytime you have division with a fraction, keep, change, flip. Keep the numerator, change division of times, flip the bottom fraction. It makes me think of KFC, and then I just flip the rest. KCF. All right. Can we find the amplitude from a graph or an equation? Yes, we can. Amplitude is how high or how low you go. In this first one, we go up to 4, down to -4. Your amplitude is 4, always positive, right? Sometimes we have a little work to do. We've already done a bunch of these. Let's remind ourselves. If we go up to 5 and down to -1, the easiest way to figure out our amplitude, anybody have an idea? Yes. Yes. Add your max to your min, divide by 2. It's just finding what's in the middle of those two. So my max is 5. My min is -1. I get 4 over 2, which is 2. And then remember, your amplitude is the distance from your midline up or midline down, right? Normally it's just 0, so it's just counting up and counting down. So now that we have our midline, it's very easy to see that we have an amp of 3. Okay? What's the amplitude here? Oh my gosh. No negatives on your amplitudes, okay? That's going to be the easiest multiple choice question you get on this test in a couple weeks. Let's not make that mistake. And what is our amplitude here? 1/2, okay? Lots of review. Last question, still review problem. Sorry, Christian, what? Okay, sorry. Yeah. That's fine. That's fine. Usually, Daniel, we use a dotted line to show like that it's understood to be there, but you don't normally use it when you graph. But it's not wrong if you can do it solid. Okay? Christian? Just 4 and 1/2. Okay? All right, last question, find the midline on a graph or in a function. We just did this one. This is the same exact graph we were just looking at. 5 plus -1 divided by 2. One thing I've been a little lazy about is, like, we'll label it. Let's make it solid for Dan. I'll put 2. It's really y equals 2. It's a line, midline, and it's a horizontal line. So technically, we should put y equals 2. That would be part of a multiple choice question for you guys anyway, so I don't think you'd get it wrong. But just in case, max plus min divided by 2. So there's my midline. Okay. What's my midline here? No, that's amplitude.
Oh, wait, no, that was the midline?
Not 4. -5. Remember, D and midline are the same thing. Because that's normally a 0, right? That means you don't go up or down at all. That -5 takes us down 5, and then we do our amplitude from there and there, okay? And our midline here is just 4, okay? D is the midline. Okay, so we're going to do, let me put the homework assignment up. I'm going to do one problem with you. The one problem that you might get stuck on if you're not careful. Number 6. Guys, there's something funky in number 6 that I need to do with you. It's a really common mistake we're going to make. I made it last year.
Is this the negative?
No, okay. So let's do number 6 together, and then the rest will be, I think, really easy. Okay, listen. Graph from here to here include the rule, okay? This is what's new right here. Normally it just says graph one cycle. They're telling us to graph a very specific part of the x-axis. They want our graph to go from -2 to 2. It could be 1 cycle, it could be 2 cycles, it could be 3 cycles. Let's see by pulling out every piece of information we have. All we have here is an A and a B, right? A is 1 with a flip, right? That's my amplitude. And B is 1/2. I need the period. We know that formula is 2 pi divided by B. Heat change flip gets me 4 pi, okay? Understand what we just found out. We just found out that 4 pi is the length of the x-axis to make 5 points. 5 points spread out over 4 pi, okay? Now, the direction said to graph from -2 pi to 2 pi. Well, what's that distance? What's the total distance from -2 pi to 2 pi? 4 pi. Distance is positive, right? From here to here is 2 pi. from here to here is 2 pi. So this is 2 pi plus 2 pi. So we're going to spread our 5 points over the whole negative 2 pi to 2 pi. Now, let's go back to what is the pattern here. Cosine is up, middle, up, but with a flip, instead of being up first, will be down. So this is optional. Just I'm keeping everything straight here. Here's the mistake I made last year, first time I graphed it and I had to fix it. And so it's easy to do. Where do you think the first place you want to start is? Oh, you want me to start at negative 2 pi? I'm going to start down there. But we don't start graphing just anywhere on a graph. We always start graphing at 0, 0. We start at the origin, unless there's a phase shift, which you haven't even learned yet. So every graph we've done starts right here. So I'm going to start here, okay? And I start by doing down first. So that's not really a point right there. I didn't mean to put that there. So down would be down at negative 1, right? So my first point is here, then middle, then up. Now understand, if I could extend this, it would keep going, right? Middle down, middle up, middle down, middle up, forever, okay? But I don't want that part. I need to figure out what's going on over here. So instead of working backwards, it's actually easier to remember something really fundamental that we learned a long time ago about periodic graphs, is that you always start and end at the same place. We only have 2 more points, right? There's 3, there's a total of 5. So we, quote unquote, ended at 2 pi, up at 1. So at negative 2 pi, we'll also be at 1. Where do you think the other point goes? In the middle. Yeah, in the middle is what I was looking for. Okay, so this is where the graph starts, and it continues. But remember, it was going on before that, too. So it actually looks like that. Okay, so always start at 0. Always start at 0 with your pattern. Okay? That would be easy to mess. That would be easy to mess up. We're going to practice a lot more graphing next week. All right, I can't put the entire key up here, but it is on Canvas. Lots of review stuff, guys. And remember, I forgot to check homework yesterday. So I want you to keep working because I know I'm giving you tons of things to think about today. But I put it up yesterday, so I told you all knew what the homework was going to be because I told you. But I'm going to come and check page 25 and 34. 25, 34. 25, 34. Okay? Ugh. That says 25 and 34. Evelyn, if you want to grab your phone and get a 3-minute timer started. Oh, would you mind? Thank you. You're so nice. Yeah. Uh-huh.
Once you try to get like the A, B, and the period, how do you figure out how to put it on the graph? 5.
So in number 5, so you agree with me as an answer period?
Yeah.
Okay? So I need to graph from negative 2 pi to 2 pi. I'm going to start at 0 here. If my period is 2 pi, that means I'm going to make 1, 2, 3, 4, 5 from 0 to 2 pi. But I need to go, that just means I'm going to have another one. Another pi. So this one happens to be like that in black. Because the period is 2 pi, or this one was 4 pi. So that was 5 points. So this is in the period. Good? You happy?
25 and 34. there. Okay, this one, I found it. Then what was the other one? 34. Oh yeah. 30, 34. There was this one as well. But, yeah, that's the one. How do you write the equation?
Plug in the A and the B.
Okay. And how do you tell if it's like sine or cosine?
The pattern, up, middle, down, middle, up, is cosine. So if it starts up or down, cosine. If it starts in the middle, it's sine.
Wait, so cosine is down, middle.
Think, we went over those the patterns in the beginning. So what's the pattern for sine?
Up, middle,
No. Sine starts in the middle.
up.
Middle, up, middle, down, middle. And cosine starts up. So number 16 is up, middle, down, middle, up. That's why 16 is cosine.
So then cosine is up, middle,
Down,
down.
middle, up.
Okay.
So I'm just practicing that to myself in my head right now. Hey. Should I say you weren't wearing your... This here. Oh, right. Yeah. I'm going to tell on you to not wear your mask. Hi guys, have a wonderful